Hello, in this video we're going to take a look at finding the equations of some transformed functions. So first I want to do a quick review of what transformations appear where in our function. So we have y equals a times f. Now the f here is going to be whatever our function is. It may be a squared or a square root or a cube root or an absolute value, or when you get into other types of functions it may be more complicated functions. This is going to focus on primarily the six main parent functions that we're going to look at are linear, quadratic, cubic, square root, cube root, and absolute value. So that f is just going to mean whatever this function is that we're looking at. What is inside those parentheses around that function is, I'm going to call that part the inside of the function. That means that's on the inside of the square, the inside of the parentheses, the inside of the absolute value. Anything on the outside is going to be on the outside of the square root, the outside of the parentheses, and so forth. All right, so if it is on the inside, that means it's going to be a horizontal change. And it is only going to change the x values. If it is on the outside, it's going to be a vertical change. And it is only going to affect the y values. All right, so what's out front, this a here is going to tell us our two things actually. It's going to give us, a is going to give us information on a vertical stretch or compression. And that's just going to depend on whether the absolute value of a is greater than 1, it's a stretch. And if the absolute value of a is less than 1, it's going to compress. And it's also going to give you some information about a vertical reflection. So if a is positive, then that means no reflection. If a is a negative number, then that means there is a vertical reflection. And that's going to be a vertical reflection is going to be something going up, flipping to something going down. All right, our B is going to give us the same information just with horizontal. So we can copy and paste all of this and replace the word vertical with the word horizontal, with one exception. It switches our stretching and compressing. So our B value is going to give us information about a horizontal change. Or a horizontal reflection. And we're going to get it if the absolute value of B is greater than 1, it actually switches. Everything on the inside does the opposite of what you would expect because it's done before we do our function, and so it ends up acting just on that x and does the opposite. So it's going to compress if B is bigger than 1. If the absolute value of B is less than 1, it's going to stretch, and we're going to be stretching it out horizontally, not vertically, but horizontally, stretching or compressing. So it's going to make it either wider or skinnier. And then if B is a negative number, we will have a horizontal reflection. And that's going to be where we're going to end up with something reflecting across the y-axis. We're going to get that reflection horizontally, like pages in a book. All right, the other letters we have here are C and D, and let me get my picture out of the way. Our C value here is going to give us information on our horizontal shift. And again, it does anything on the inside, does the opposite of what you would expect. And so if C is positive, that means we are going to the left. If C is negative, that means we're going to the right. And actually, let me make this a little bit, make it a little bit more straightforward. Normally we do a minus there and then our C does exactly what we expect. But most of the time students want to look at whether C is a positive or negative. So I'll go ahead and put that as a plus C. And then our D is our vertical shift. And it is going to be, if D is a positive number, we're going to go up that many. And if D is a negative number, we're going to go down that many. All right, so let's look at some of these. All we're doing here is finding the equation. So if we want the equation of the graph where y equals x cubed is shifted to the left 6. Well, shifted tells us that it's going to be a plus, and then this is giving us left, so that means it's a horizontal. Well, if we go back up here, remember our horizontal shift is our C value. So that's where we're adding or subtracting something on our x on the inside. So we're going to write this on the inside of our function. If we're going to the left 6, that means we're going to have a plus 6, because remember, anything on the inside does the opposite of what you would expect. So a positive number inside there is going to the left. And that's your answer. And you can always graph this on your calculator and graph your original y equal x cubed and the answer that you get and see if you do have that transformation. All right, if we want to find the equation of the graph for the function y equal absolute value of x vertically stretched by a factor of 3, well, vertical means that it's going to be on the outside, so we're still going to have our absolute value of x on the inside. And if we vertically stretch by a factor of 3, that means our number out front needs to be a number bigger than 1, right here. And so if it's by a factor of 3, well, 3 is already bigger than 1. So the graph of the absolute value that's vertically stretched by a factor of 3 is y equal 3 times the absolute value of x. All right, this last example we're looking at has 3 different transformations. So I'm gonna do these just piece by piece. So our first one, we want to look at the graph of the square root of x that's vertically compressed by a factor of 3. Well, the previous example we did a vertically stretched by a factor of 3 and we multiplied by 3 outside. If we want to compress it by a factor of 3, then we are going to multiply by 1/3. We want to make it 1/3 the width, or 3 times smaller, and because it is a vertical, that is going to be on the outside of our function. All right, our next example, we are going to shift it up 1. So when we shift up 1, up is a vertical change, so that means it's going to be on the outside. And if we look back at our little cheat sheet up here, if D is positive, we're going to go up. And so we're going to do, again, vertical is on the outside of our function, so it's going to be on the outside of our square root, and we're going to have a +1 on there. Our last transformation we're going to look at is shifted right 5. Well, to the right is a horizontal change. That means we're going to have something on the inside of our square root. And if we want it to go to the right 5 means that we are going to have a negative number where our c is, so we're going to get x plus c, x plus c, or in this case, x plus 5. And that will be the graph that has those 3 transformations. If we had a negative in there, we would want to make sure and distribute that negative if it wasn't our last step. All right, I will see you guys next time.